So 28 students have joined. We can start. Okay. So last class, I told that I will give you the notes for your intake structures we have learned. We have learned about the points that we should keep in mind when selecting the intake site. So I'm sharing my screen this week. So you can take a screenshot of this. Are you able to see my screen? Yes or no? Yes.
Yes, ma'am.
So just take a screenshot and later you write down in your copy, okay? The definition of intake, the basic function of an intake, it is already marked. I have already kept it marked in my book. So you can just see the this basic function. You take a screenshot and then you take a screenshot of this factors. Then this you take a screenshot. So 5 6 points if you write then it's fine. Okay, no need for 7 8 points. Those 5 points you write down or 6 points you write down. Okay, and this one you that day I told you to write about one of the intake type, that is your simple submerged intake. So I am giving you this picture so you can write it from here also. If you cannot find it in Google, then you can write it. You can take a screenshot this one. Taken. This is the drawing this way. One by one screenshot you take. Take this one screenshot. Then this one you take the screenshot. Okay. This one you can take the screenshot. Okay. The next type of tower, intake tower actually, you can take it. Okay. So you have taken the screenshots, I guess. Anyone left out to take the screenshot? You can make this drawing. Okay. This drawing you can make and you can write briefly. You can write it down the submerged intake. The initial first diagram is this one. This is the first one. It's a little bit hazy, but then also I think you can see. This is the first one, and this is the second one. You can draw only one, okay? It's no need to draw two diagrams, only one, it's fine. You can draw this one, simple concrete block. You can take the first diagram, you can draw. Okay, okay, so I'm closing this one, okay? I hope everyone has taken the screenshots. By chance, if you need the PDF, I can share it with you in your group, okay? Okay, so mm, today, after your intake, we have to study about the pumps, okay? Not very thoroughly, but just you should have the idea about the pumps, what are the different types of pumps, and what are the means, in what case your pumps are required, okay? So that much is sufficient for you to know, okay? So you see pumps, everyone, you see when pumps are used, here 4 points are mentioned, okay? Here 4 points are mentioned, you can see this way. Let me, okay. So this is your first point. You see what it's written? To lift the water. Just wait. Okay. You can take a screenshot, okay? Or if you want to write, you can write down, no problem. The first point is written as that to lift the water at the source when the water cannot flow by gravity into the mains, such as in the case of low-level surface sources and groundwater sources. Yes, I have shown you that day the diagram of a reservoir, right? So if the water, the source of supply it is a reservoir that is at a higher elevation, okay. So in that case, your pump is not required because the water, obviously, the water it is at a source of supply is at a higher level, so the water it can automatically through the act of gravity, it flows to your distribution means or it flows to your water treatment plant. Okay, but in every case, it might not be like that. That the water source of supply is at a higher level. Okay, so sometimes the water it might be at a lower level also. Okay, so when the source of supply is at it is a low level surface source, in that case your pump is required, okay, so that it lifts the water to the treatment plant, okay, or to the intake. Okay, number 2 point you see, it's written here, to lift the water at the treatment plant if sufficient natural slope is not available as to cause gravitational flow between different units of the treatment plant. Yes. So you see, one is at a higher elevation and the treatment plant is at a lower elevation. So there is a sufficient slope. Okay, a slope is there. So if that slope is not there, if the natural slope is not available, so that the gravitational flow it can happen, Okay, so in that case, your pump is required to leave the water to the treatment plant. Okay, so next point, let us see. It's written as to leave the water after the treatment so as to force the water into the distributing mains either directly or through a service reservoir. So after the treatment is done, so to take the water to the distributing mains, okay, to the distribution system. Then also, if there is no natural slope, or it is the treatment plant is at a lower level and the distributing mains is at a higher level, in that case also your pump is required to leave the water directly to the distribution mains. Okay, so next is your number 4 point. You see, when the pressure in the distribution mains has to be increased or boosted at some intermediate points within the distribution system so as to enable the water reach up to the required height of 3 stories. Okay, not only 3 stories, it nowadays the buildings are G+4, G+5, G+6. Okay, so when the pressure in your distribution mains, okay, when the pressure in the distribution mains, it has to be increased, okay, at some points. Okay, at some points of the distribution mains, the pressure needs to be increased. In that case, in order to the water to reach the seventh floor, sixth floor, fifth floor, what happens? Pumps are required. These things you already know, I guess. Okay, but then also I'm just explaining. So these four are the what? These are the requirements of pumps. Okay, when pumps are generally used. So these 4 points you can take a screenshot and you can write it down in your copy later. Okay. Next, sorry. Next, let me see. Let me write this one. Okay. Next, you just need to know about the types of pumps. Okay, you need to know about the types of pumps. So these pumps, turbines, all these things, I guess you have learned in your hydraulic machines about turbines and also pumps. Also, I think you have learned about this. Okay, but you just need to know about the types. Okay, you just need to know about the types. Just remember the types. So you see here types of pumps. There are two types of pumps. Okay, one is your rotodynamic pumps and the second is your displacement pumps. Okay, you can write it down, later you can remember. So one is your rotodynamic pumps and the second is your displacement pumps. So what is a rotodynamic pump? It is written here, a rotodynamic pump has a wheel. Okay, this one. A rotodynamic pump has a wheel or a rotating element which rotates the water in a casing and thus imparting energy to the water. So, a rotating pump, it is said that it is having a rotating element or a wheel type structure in its casing, and it imparts the energy to the water. Okay, so what are the types of rotodynamic pumps? The types of rotodynamic pumps are centrifugal pump and axial flow pump. Okay, so let's see what's a displacement pump. So a displacement pump, what is written here? A displacement pump works on the principle of mechanically inducing vacuum in a chamber, thereby drawing in a volume of water which is then mechanically displaced and forced out of the chamber. That means a displacement pump, it works on the principle of what? It creates vacuum. Okay, it creates vacuum in its chamber, and what it does? It draws water and then which is mechanically displaced and it is forced out of the chamber. Okay, the water is forced out of the chamber. The main principle is that a displacement pump, it induces vacuum in its chamber. Okay, so what are its wait. So what are its types? It has two types. One is your reciprocating pump, and the other one is your rotary type pump. Okay, so this you can, if you remember these types, then it's fine for your this one. Okay, so this much you remember about pumps, the types of pumps, and under what conditions your pump is required. Okay, then you have taken screenshot. You take a screenshot. Please don't leave
Yes, ma'am.
all these things like this for today. You have learned, you have taken screenshot. Don't leave it like that. Okay, so since now you don't have any work, and also after your class ends, when at 2 p.m. your class ends, so you take rest. Okay, in the evening you please write all these things in your copy. Otherwise, what will happen during your exam, everything will be misplaced. Okay, and sometimes if you take all these things in your mobile, if somehow your pictures gets deleted, then all these things will go. Okay, so it's better if you today you have done the class, you remember that man has told to write this, that, so you write it down in your copy serially, and it will be good for you. Okay, so that's why I'm telling, just don't keep it in your mobile like this. Okay, so pumps you have done. You have known when to use pumps. So after your pumps, this also you have taken screenshot, I guess. Okay, 1, 2, 3, 4 points. Next, we will go to learn about the characteristics of water. Okay, just wait. Okay, okay. Now, characteristics of water we will learn. Okay, that means the quality of water. See, from the first day itself, we have been talking about like we take the water from the source. Yes, we take the water from the source. Then it is taken to a treatment plant. The water is treated. Okay, so what are the characteristics? Okay, what are the characteristics that a engineer he should check? Okay, what are the suppose sometimes before your treatment? Okay, so we should know the characteristics of water which are to be checked before it is supplied to the public. Okay, in order to ensure health, economy, all those things. Okay, to give a very good health of the engineer, he cannot just take the water from the source and he just give it to the supply it to the public. Okay, he should know some characteristics, what are the things that should be measured. Okay, what are the permissible limits, all those things we should know. So your characteristics of water, there are three characteristics. Okay, so there are three characteristics you see here. This you see the physical, chemical, and microscopical characteristics. Okay, these three are the characteristics of water. Microscopical, or you can say biological characteristics also. Okay, physical, chemical, and biological characteristics of water. These are the three characteristics. Okay, that should be checked and tested. Okay, before supplying it to the public. So we will first study about the physical characteristics. We will see what are the physical characteristics. You can write the heading. You write your heading as your physical characteristics. Okay. So in your physical characteristics, you can write it down. You are having this characteristics: turbidity, color, taste or odor, temperature, and specific conductivity. Okay. Physical characteristics, it includes your turbidity, color, taste, odor, temperature, and your specific conductivity. So first we will learn about your turbidity. Okay, we will learn about turbidity. Okay, so what is turbidity? Okay, so suppose you are taking a distilled water. Okay, you are taking a distilled water and you are putting some sand into it. Okay, you have put some sand into your distilled water and you stir it. Okay, because the sand, obviously after some time the sand will get deposited at the bottom, but you stir it. Okay, so when you stir it, you can see the color of the water. It is from, from colorless, it is becoming somewhat color brown. Okay, okay, brown, or you can say the water is appearing to be muddy. Okay, so that thing, it is known as turbid. Okay, so that is your turbid. So if a large amount of suspended matter, okay, you can, it is written here, you see, if a large amount of suspended matter such as clay, silt, or some other finely divided organic materials are present in water, it will appear to be muddy or cloudy or turbid in appearance. Okay, so that means turbidity, it can happen if a large amount of suspended matter. Okay, suspended matter like what? Clay, silt, or you sand, all these things are present in water, or also some vegetations are present in water. Then what will happen? The water, it will appear to be somewhat muddy, or you can just see with your naked eyes. Okay, that means turbidity you can see with your naked eyes. So if when the water, it is not it is not clear, okay, the water seems to be muddy, then that is known as your turbidity. Okay, so that term, you don't say that the water is appearing to be muddy or cloudy, you don't say like that. Okay, so in engineering term, you will say that the water is turbid. Okay, so turbidity, I think it's clear. Okay, so let's see the lines which I am putting red. You write these lines in your copy. Okay, these lines you need to write it down. The important lines, I will just mark it. Okay, so uh, wait, next, okay, so these muddy things, this clay or silt or sand, okay, or the vegetations, suppose you can drink that water. Okay, if you drink that water, if that uh, in some amount it is present, and if you drink that water, that sand silt, it will not harm you. Okay, it will not harm you to that extent. Okay, to that level it will not harm you, but will you be able to drink that water? Obviously no. Okay, if something is you are seeing with your naked eyes that something is there in the water, it is appearing to be turbid, so we will not drink that water. Okay, so that what government has done, okay, what government has done is that the turbidity, they have given some permissible limits for turbidity. Okay, that this much, if this much of turbidity if it is present in water, then it is the people can drink it. Okay, so people can drink it, or the it will become invisible, means with naked eyes also you cannot see. Okay, that much the water is treated, it is measured, and it is measured, and the permissible limit is also given to you, okay, by the government of India. So you see here one line, this one, this is already marked. Okay, just see from here to here. Okay, what it's written, the turbidity is measured by a turbidity rod. Okay, or by a turbidimeter with optical observations, and is expressed as the amount of suspended matter in milligram per liter or ppm. So this line, what does it mean? So it is told that the turbidity, it is measured. Okay, the turbidity, it can be measured by a turbidity rod, and turbidity rod, it is used in your practical fields. Okay, turbidity rod is used in your practical field, and turbidimeter is used in your practical lab. Okay, in your lab, when experiments are done, you use turbidimeter, and in your practical fields turbidity rod is used. Okay, so what is the unit for turbidity when it is measured? The unit is milligram per liter or ppm. Okay, so milligram per liter or ppm full form, you can write it down. The full form is parts per million. Just wait, huh?
Ma'am, can you repeat
Yeah,
it
yeah,
please?
I'm writing it down. Parts
Okay.
per million. Okay, parts per million. You remember here one thing also. 1 milligram per liter is equal to 1 ppm. That means if someone says you that in this sample of raw water, suppose 5 ppm of turbidity is present. Okay, that means you will get to know that in that sample of water 5 milligram per liter turbid is present. Okay, that means milligram per liter or ppm is the same thing. Okay, so here when we measure turbidity, okay, so we have some scale. Okay, the turbidity rod or the turbidimeter, it has some scale in which the turbidity is measured. So what is that scale? You see, it is written here. The standard unit is that which is produced by 1 milligram of finely divided silica in 1 liter of distilled water. Okay, okay, where it went? So sorry, it went back from here, right? From here. These lines you write in your copy, okay? So what it is written here is that uh, The standard unit is that which is produced by 1 milligram of finely divided silica in 1 liter of distilled water. This means that in 1 liter of distilled water, 1 milligram of silica is present. Okay, if suppose someone says you that in this sample of water, you know the turbidity is someone says you that it is 5 milligram per liter. Okay, so that means in 1 liter of distilled water, your 5 milligram of silica is present. Okay, did you understand the point? If someone says you that in a sample of water 5 milligram of turbid is present, 5 milligram of turbidity is present, or 5 ppm of turbidity is present, that means that 1 liter of distilled water, it contains 5 milligram of your silica, finely divided silica. Okay, so turbidity, it is based on your silica scale. You remember that one. Okay, sometimes in your competitive exams, your these short mcqs come, so you have to remember all these things. Okay, next, one more line you can add. Okay, so a turbidity in excess of 5 units is easily detectable in a glass of water. That means 5 milligram per liter. Okay, if 5 milligram of 5 milligram per liter of turbidity it is present in water, then it is easily detectable in a glass of water, and you can easily see with your naked eyes. Okay, so let's see the next. Okay, so here the permissible limit, it is written, you see, this one. A permissible limit of 5 to 10 units of turbidity for drinking waters. Okay, so what is the permissible limit? Permissible limit of turbidity is 5 to 10 milligram per liter. You can write down. Okay, no issues. You can write down 5 to 10 milligram per liter. Permissible limit for turbidity for drinking water. Okay. Okay. So next. Okay. So you see, this is the image of your turbidity rod. Okay. You see this one, this diagram. This is a turbidity rod. You know how it is done. Suppose here you see what things are present. This is a eye mark. Okay, you can see here it is a, so eye mark is here, you can see through this eye mark. Okay, and here this is a graduated tap, and graduated tape, it is your here it is 1220 millimeter. Okay, this part is your 1220 millimeter, and this is a graduated tape. Okay, so it's a long. Okay, here break line is given here, and here it is a aluminium rod. This is a aluminium rod. Okay, this part. Okay, this part is your aluminium rod, and it is your 230 mm. Here a nickel ring is present here at the bottom, and a platinum needle is also present. Okay, so how it is done? Suppose you are taking a beaker, okay, or any this one you have taken, and you dip your turbidity rod in that sample of water. Okay, you dip that this turbidity rod in that sample of water, and you see through this eye mark. Your eye mark is given, you see through this eye mark, and you try to see this needle. okay, and you try to see this needle. So you are taking a turbid water and you are dipping it in your that sample of water, and you see through the eye mark and you see this platinum needle, okay. So as long as you see, you keep on dipping it until and unless the platinum needle it disappears, okay. So you dip it, you are seeing the platinum needle after some time, okay. After some time you are keep on dipping it, and after some time at a certain depth, okay, at a certain depth what will happen, the this platinum needle it will disappear, okay. As soon as at that point, as soon as the platinum needle disappears, you need to see the graduations on your scale, okay. You need to see how much water level it is marked on your graduation scale, and that will be your turbid, okay. That much turbidity it is present in your that sample of water. That is how your turbidity rod works, okay. So about turbidimeter, okay, about turbidimeters, you can uh, there are three types of turbidimeters, okay. So there are, let me mark it. About turbidimeters, you can write it down. There are three types. Number one is your Jackson turbidimeter, okay, and just write the you know uh, the range, okay. You just write the range in your site. For Jackson turbidimeter, the range is between 25 to 1000 milligram per liter. Okay, it is used to measure turbidities in the range between 25 to 1000 milligram per liter. This much, if you remember, then it's sufficient. Okay, everyone, please write it down. For Jackson turbidimeter, your turbidity range is between 25 to 1000 milligram per liter. Okay, next. It will end in 5 minutes. No issues. Let's see. Next, you see, this cursor is not working. Next is your Bailey's turbidimeter. Okay. So for Bailey's turbidimeter, oh sorry, can you see it? Okay, now it's better. Bailey's turbidimeter, you write down. Okay, and you write the range. Okay, it measures in the range between your 0 to 10 milligram per liter. 0 to 10 milligram per liter. Written, everyone. Bailey's turbidimeter. The range is between your 0 to 10 milligram per liter. Next. Number 3 is your, just wait. Okay. So number 3 is your NTU. This one is already marked, you see here. NTU, or you can write it down, nephelometric turbidity units. Please write it down. NTU, nephelometric turbidity units. Okay, and occasionally, sometimes your this nephelometric turbidity unit, it is also termed as your FTU, which is your formazine turbidity unit. Okay, this is when your formazine polymer, one polymer is there named as formazine. Okay, so formazine polymer, when it is used as a reference, then turbidity standard suspension in a place of silica suspension. That means in your turbidity, we have learned that it is silica scale is used. Yes, silica scale is used, but in that place of silica, if sometimes yeah, formazine is used, then it is the unit, it is known as your formazine turbidity unit. Just remember it. Okay, the names you remember: nephelometric turbidity unit and your formazine turbidity unit. Okay, so the meeting, it will end now. After your turbidity, the next one is your color. Okay, next one is your color. So shall we end it, or uh, what's the time now? It's 10:05. 10:05. Next class is from your 10. Okay, we will continue. Okay, if the meeting ends, you